Hey there, welcome back to Escalation. In today's video, we are discussing about another fundamental data type in Python, which are sets. By the end of this video, you will understand what sets are, how to use them, and why they are unique compared to other data types. Let us jump right in. The first question is, what are sets? A set is a collection of unique elements that is unordered and unindexed. That means the elements do not have a defined order or an index. In Python, there are 4 data types that can be grouped to be called as sequence data types. Sequential data types are those that can hold multiple items in it, which includes a list, dictionary, tuples, and sets. All sequence data types looks very similar to each other when it comes to syntax. For example, when we are creating lists, we enclose items inside square brackets and we separate each value with a comma. Similarly, when creating a dictionary, we enclose key value pairs with curly brackets and separate each pair with a comma. In our previous video, we also learned the syntax of tuples, where we create a tuple by using round brackets on either sides and separate values with comma. Likewise, sets also looks very similar in which we enclose the items with curly brackets like a dictionary, but here there is no concept of key value pairs. Instead, it's single item separated with comma. It is like merging a dictionary and a list. Now comes the next question on how sets are different from any of these data types. For that to understand, we will have to discuss 5 different features of sets. Did you know that sets will not hold duplicate values in it? Yes, sets will not store duplicate values in it. Let's try creating some sets to test this particular feature. For beginners, let me just add duplicate values of some integers, and now when I print this, we see all unique values in a set. Now let's include a string inside this set to check if this works for strings as well. And yes, it does work with strings as well. You may explore this feature by using multiple values and try printing it to see how sets function. Moving on to the second feature, sets are unordered, as we defined a set at the beginning of this video. What do you mean by ordered or unordered data type? In Python, an ordered data structure is one where the elements have a specific sequence, and this sequence is preserved. That means you can access elements using an index, and they will always appear in the same order. Lists and tuples are both ordered data types where we can access the items from these based on indexes or their fixed locations. Now you can relate to what are unordered data types. These are the data types where the elements do not have a specific sequence. This means you cannot rely on the order of the elements, and there is no concept of index to access them. Dictionaries and sets are examples of unordered data types. In a dictionary, we always access an item through a key, but how it's stored is what we learned from a hash table structure, where it gets stored depending on the hashing value and we cannot access them using index. Now, sets are also unordered, but the difference being, in a dictionary we can at least access items based on the key, but in sets we cannot perform this operation at all, which means we cannot change or update a value based on its location. A point to remember about nested data types in a set is, unlike in lists, tuples or dictionaries where there is no restriction to data types inside them, as in, we can include a tuple or a dictionary inside a list, or nest a dictionary or a list or another tuple inside a tuple, etc. But in a set, we cannot include any sequential data types in it except for tuples. In other words, we cannot include any immutable data types inside a set. Sets are mutable. That means, though we cannot access them by their indexes, we can perform operations like adding a new item by using a function add, and similarly remove items from the set using remove. When we look at the memory locations of these sets before and after updates, we will see no change in the location, which means it is updating the same object and not creating a new one for these changes. You might have studied sets in your high school through Venn diagrams. and those are the operations that can be performed here as well. That includes union, where I want to combine all the elements from a bunch of sets. Here, I will create two sets for illustration, and we can combine these two sets by using pipe. Again, it will remove any duplicates found here. Similarly, I can use an ampersand to find the intersection of sets. Finally, to get the difference, we can use the minus symbol. By the way, these does not work the same way for other data types, and hence this feature is unique to sets alone. Now that we understood what sets are, it's time to explore Python's offering of frozen set as another data type. Well, these are also sets, but the ones that does not allow any changes to it, which is similar to the functionality of a tuple. We can use Python's built-in function frozen set to create this data type. When you check the data type of this object, it will return the type as frozen set itself. Two major differences between a set and a frozen set are: 1. Mutability, where sets allow operations to add an item or delete elements. However, frozen set by name restricts these operations. Second, a normal set cannot be used as a key in a dictionary, whereas a frozen set can be, and that is due to the mutability nature of the data type. To summarize, we learned what are sets, syntax of it, features that includes uniqueness. Sets are unordered, where we also learned what are unordered and ordered data sets, mutability, restrictions of nesting other data types, and a bit of operations that can be performed on sets. We also looked at a new data type, that is frozen set, and looked at the differences between a set and a frozen set. Hope this video was helpful in understanding another important data type in Python. Drop a comment if you have any questions, and do not forget to share, subscribe, and like this video.